Hi, hello everybody. So this is the video dealing with section 3.3, properties of logarithms, and this is the second part where we're going to condense the logs. So we're still going to use the same three properties that we've seen before, the product rule, where we have now in reverse. So you remember from before we had log of a product on the left side. Now we have it on the right side because we're going to use it to start with multiple log expressions, in this case two, but there could be more, and we're going to condense so that the final answer has a single log expression. So log of a sum is the product of the two logs. Log of a difference is the log of the quotient. And if we have a number multiplying the log, this is the power rule. That number becomes the exponent of the log. Now, keep in mind that just as in the first case, that for this to happen, for these properties to happen, for the first two properties to happen, the base has to be the same. All right? The same thing for expanding logs. So the bases have to be the same. Now, again, in the process of either condensing or expanding logs, the base has to be a positive number greater than 0, but not 1, which is going to be our case. Along the way, if it is possible, we are going to have to simplify numerical log expressions. Okay, so this is exactly what I'm saying here. Whenever possible, whether expanding or condensing, we must always simplify numerical logs whenever possible. All right, so let's take a look at the examples I have here, and I'll leave the properties visible for you to see. Again, this is a review from Math 119. If you need more clarifications, you can always search online or your notes for how to either condense or expand logs. All right, so let's see the first example. Both are taken from the textbook, so you can see the details over there if what I'm reviewing here is not enough. All right, so let's take a look at log base 4 of 2 plus log base 4 of 32. So when we have a problem like this, before we evaluate each log, in this case, neither one is possible, we want to condense them first. So I will apply, obviously, the first property, which is log of a sum is the log of their product. So this is going to be provided that the bases are the same, which in this case they are. So this is log base 4, 2 times 32, which is log base 4 of 64. And now at this point, I ask myself, is this possible that I can simplify this numerical expression? Well, let's see. To evaluate this log, I need to find an exponent that goes here such that the 4 raised to that exponent is 64. Can you find such a number? Well, yeah, it's 3, right? Because 4 times 4 times 4 is 64. So this entire expression simplifies to the number 3. Okay, and if this is a question on the exam, this is exactly what you would show us on the exam. Okay, very good. So that was the first one, numerical log. Right, so erase that. So let's do the other two, which are not necessarily numerical. Let's take a look at A. 1/2 log x. And this is a good example, and I'm going to tell you why. Log x minus 1. So notice that from this example, I do not see the base, right? The base seems to be missing. Well, this is similar to, for example, let's say square root of 16. I don't see the number here, right? Because by default, if I don't see the index on the square root, The number is 2. Well, similarly, on a log expression, if I don't see the number, it means that by default, the number is 10. So this is called a common log, base 10. So invisibly, you see the number 10 right here. We just don't write it for base 10. Okay, so this is one important fact. Another important fact is that when we were expanding logs, I told you that the power rule is always last. When we are condensing logs, it's exactly the opposite. So the power rule when we're condensing is first. So this number has to come right here first. This number has to come right there first. So this is going to be log base 10. You don't have to write it. X to the 1/2 plus log base 10 x to the 4th. Okay? And now I will convert this to radical form. So you remember how that goes, right? The x is the radicand, the 1 is the exponent here, and the denominator is the index. So this is square root of x. So I'm going to write it as log base 10 radical x. And notice I'm not going to write the base anymore. Plus log x minus 1 to the 4th. And now finally, after I've done the power rule, I notice that I have an addition. So this is going to be log of their product. Okay, so log base 10, radical x, x minus 1 to the 4th. So this is my final answer for that problem A. Okay, so condensing logs. I will start with multiple log expressions, and I'm going to end up with a single one, which is what you see right here. All right, very good. So that's the first one. Let's do the second one now. I'm going to erase all of this. So second expression, B. I'm sorry, I was going to do C. Okay, so second expression, 3 ln, another very good problem, plus 7 minus ln x. So notice that the ln is not even log for log. So instead of log, if you have an expression that instead of log says ln, this is notation for log base e. So e is that special number, and this is called a natural log. Okay, it's a special base, just like base 10 is called common log. So ln means actually this, log base e of x plus 7 minus log base e of x. Now, I'm not going to write e, I'm just writing here to show you that that's what ln means, natural log. Okay, so I don't have to convert any radical forms to exponential, so I can immediately apply, in this case, the power rule right here. So remember, the power rule on condensing is done first. So ln x plus 7 to the 3rd minus ln x. And now I will apply the quotient rule because I have a minus. And notice how the answer is. And I'm going to write it correctly, and then I'm going to write the incorrect way because I don't want you to make that mistake. So this is the correct way. Natural log x plus 7 to the 3rd power over x. This is the answer. This is the correct answer. Now, what students would do sometimes incorrectly is do the following. Natural log x plus 7 to the 3rd over, either they will say over x, which is incorrect. Notice the correct answer. Or they would say this. So this is extremely wrong. Do not do it. This is the correct answer for the second one. Okay. So notice the quotient rule, right? You don't have natural log and then over everything, the other factor, right? Right, so pay attention to that. So that's the second case. Let's do the third case now, or the third example, which is this. So I have 4. Again, I have a generic base, which it's not mentioned, but that's perfectly fine. Minus 2 log base b of 6 minus 1/2 log base b of y. So as I can see here, I have a factor multiplying each of the logs. So I have to apply the power rule first. So the 4 goes right there. The 2 goes to the 6. And the 1/2 goes to the y. Now notice, not the sign, just the number. Okay, so the first expression is going to become log base b of x to the 4th minus log base b of 6 squared minus log base b of y to the 1/2. Now I'm going to write 6 squared is 36 and y to the 1/2, as you probably already know, square root of y. So my third or second line would be log base b x to the 4th minus log base b of 36 minus log square root of y. And now I will apply the quotient rule, but I have to be careful because I have to apply it only one at a time. So I'm going to do the quotient rule here. So this is going to be log base b x to the 4th over 36, and then minus the log base b of square root of y. And now I do it again. Okay? So this is going to be log base b x to the 4th, and here's my 36 square root of y. All right, and this is my final answer. If you want, you can always put parentheses around here, but it's not necessary. Okay? Not necessary to do that. So here's my final answer. So again, so in condensing logs, I begin with multiple log expressions, and I end up with a single log expression. In this case, x to the 4th over 36 square root of y. And this is the second part where we are condensing logs. So in the third part, we're going to see that sometimes it's necessary to evaluate numerically a log using a different method with the calculator. So we'll see that in the third part.